for that. You were completing the guided notes for writing and balancing chemical equations, okay, in Edgenuity. Okay, so you were learning about the foundation, how to write chemical equations and how to balance them. Okay, in order to write chemical equations, what do you need to know? You need to know how to write the chemical formula for covalent and ionic compounds and, bueno, acids. But you know that acids are also ionic compounds. You need to know that, okay? Plus other things that you're going to learn today. But for today, that's what we're going to do. Do you have there a chemical change? Okay, they don't want to talk, okay? Do you have there a chemical change, Ame? Yes. How do you know that? Okay. Not talking, but over here I have the iron. Iron solid. See, I have my bottle of iron fillings, and then I'm going to put the iron over here. So, over here I have hydrochloric acid. See, this is my bottle of hydrochloric acid. Do you see that there? Hydrochloric acid. Iron solid and hydrochloric acid. According to Ame, we have a chemical change, but he couldn't explain why. So I'm going to put that together. And I want you to take a look at that. Do you see that? What do you see in there? What is a sign that you see in there that is telling you a chemical reaction is taking place? What do you see in there? No, you don't want to talk. Let me click on the shot over here. Okay. Yes, see? You see a lot of bubbling in there. Okay, and if you look closely, you can see like a fume getting out. See, look at the bottom. See, you see the bubbles in there. Let me see. Let me put that over here so they see that, and little by little it's going to start seeing. If you look at the surface, you can see.
Miss, I don't think you have your camera on your iPad.
See, you can see over there. See the bubbling in there? Okay, that's an indication that you have a chemical change. Okay? That's an indication a chemical change that you have a chemical change. Okay, they don't want to talk. Okay? Do you have the reaction that I was showing to you is solid iron. You saw that was solid iron. Okay? Reacting with hydrochloric acid. You have the hydrochloric acid over here. You were observing a lot of bubbles. You don't know what is formed because until now you don't know what type of reaction is that one. But I'm telling you that when solid iron was reacting with hydrochloric acid, okay, iron 3 chloride was produced while releasing hydrogen, which is the bubbles that you observe in there. Ms. Ramos, what are you going over this? What is that you're showing there? This is a word equation. Word equation. I'm describing a chemical change using words. Questions about that? No? Okay. Now, Ms. Ramos, there's a way that we can transform that into a chemical equation. Yes. What is the difference of chemical equations? When you are using symbols to represent the chemical change. And that's what I'm going to do. Okay. Iron. What is the symbol for iron? Iron solid. That's the state of matter. A state of matter. Was reacting, okay, with hydrochloric acid. And you know the hydrochloric acid, they have to be in an aqueous medium just to be an acid. To produce iron trichloride. Okay, by the way, I'm going to show you that one more time. See over there? It's a solid that is in there. Solid that is in there. Plus the hydrogen gas that was released. Ms. Ramos, what is this? This is what we call a skeleton equation. What do you have, or what do you need to write in a skeleton equation? You're going to be using the symbol of the compounds and elements involved, a stoichiometer. This arrow over there is separating the reactants from the products and means yields or produce, okay, that arrow in there, meaning that the reactants that were combining, and they were combining just to give you the products in there, and that's it. So you have the symbol of the element or compound, you have the stoichiometer in there, you have the arrow that means yields, and you have the products are reacted represented in your skeleton equation. Ms. Ramos, why an skeleton equation? What is an skeleton equation? Look over here. Okay? How many atoms do you have over there of iron? Only one, because you don't have a subscript. How many do you have here? Only one. Look at the chlorine. How many do you have in the reactants? You have only one. But if you look over here in the product, you have 3 atoms of chlorine. Is that possible? Matter can come out of nowhere. How come, Ms. Ramos, at the beginning I have only one, now I have 3? That is impossible. That's what we call that equation and a skeleton equation, because it's not balanced. According to the law of conservation of mass, mass cannot be created, destroyed, only transform. Is possible to have one and all of a sudden have 3? No. Ms. Ramos, what are we going to do just to fix that skeleton equation? You have to balance that skeleton equations. I'm going to continue. Okay, Ms. Ramos, okay, we understand that you have over here iron, that is solid, you were showing that to us, that is reacting with hydrochloric acid in an aqueous, in an aqueous medium in there, because it's an acid, producing iron trichloride, which is solid, because we saw that on the test tube, plus the bubbles that are the hydrogen gas that was released. Okay, we have a problem, Ms. Ramos. What are you putting that to over there? What, instead of putting H, which is the symbol that is representing hydrogen, you are just putting over there, okay, H with a subscript of 2. The answer is simple, okay? It's simple. Diatomic molecules, do you remember that? Diatomic molecules. See, what are the molecules that are diatomic? Diatomic molecules. Okay? Hydrogen, oxygen, nitrogen, and all the halogens. When they are in a chemical reaction by themselves, they are in the form of diatomic molecules, so you have to put the subscript in there. Understand what I'm saying? For example, let's say that you have carbon, solid, reacting with oxygen. Since oxygen is a diatomic molecule, you have to put the 2 over there. Okay? So carbon plus oxygen, you have to put the 2 over there because it's a diatomic molecule. They combine. Okay, the arrow in there letting you know that it's yielding that to create carbon monoxide, which is a gas. See that I was putting over here. putting over here the 2, because when oxygen, hydrogen, nitrogen, and all the halogen, they are part of a chemical equation, but they are by themselves, not as a part of a compound. They are in the form of diatomic molecule. See that? This is another example. See, look over here. I have one carbon atom in the product. Remember, this part of the equation, the arrow is dividing the reactants from the products. And according to the law of conservation of mass, you will have the same amount of the element at the beginning and at the end. It's not going to disappear. See? It's not going to disappear. It's not going to come out of nowhere. Okay? According to the law of conservation of mass. So if you look over here, you have one atom of carbon in the reactants, and you have one atom of carbon in the product. You have 2 of oxygen in the reactants, but you have only 1 in the products. Meaning that this equation, this chemical equation, is unbalanced. It is unbalanced. That's why we call that equation the skeleton equation. How are we going to balance that? We are going to use coefficients. Coefficients. Can I do this? That is not a coefficient. That is a subscript. And CO is not the same as CO2. In my equation or in my reaction, carbon and oxygen, they were mixing together to create carbon monoxide, no carbon dioxide. See that? You cannot balance a chemical equation using a subscript. You have to use a coefficient. Remember what is a coefficient? And I'm going to show you an example. An example, when you are solving a math problem, okay, before the variables, see, you have a coefficient in there. Yes or no? That big number that you have in front of your variable and is multiplying your variable is called a coefficient. In chemistry, we have coefficient too. We are going to place them in front of the element symbol of the compounds, and they're going to be multiplying the entire compound or the elements in there. Questions about that? That's your first step. When you're balancing a chemical equation, your first step is just to divide the reactant from the product. And then you're going to start counting. Counting the number of atoms of each element. Hydrogen and oxygen. Pay attention to that. This is not the first time that you're learning about this. Hydrogen and oxygen are the last one to balance. That's a rule. So carbon, I have one over here. Carbon, I have one of my products. Oxygen, I have 2 in my reactants. Oxygen, I have only 1. Let me wait for that just to show in there. Okay, you have 1 in the reactants of carbon. You have 1 on the product, so you're fine. But if you look at the oxygen, you have 2 in the reactants, and then you have 1 on the products. What are you going to use just to balance that? Are you going to use a subscript? The answer is no. You're going to use a coefficient. See, you're going to multiply by 2. Ms. Ramos, where am I going to put that 2? In front of the compound. See that? Because now you have 2 oxygen, because that 2 is multiplying the oxygen that you have in there. And I have 2, Ms. Ramos. But when I was putting that 2 in front of the carbon dioxide, I was multiplying the carbon by 2 too. And now I have 2 atoms of carbon. How am I going to fix that? You have to go back to the reactants. And over here, you have to multiply by 2. Where are you going to put these 2? In front of the carbon. And now you're going to check. So you have 2 carbons in the reactants, 2 carbons in the products. You have 2 oxygen in the reactants, then you have 2 oxygen in your product. So I'm going to rewrite my balanced chemical equation. I don't have a skeleton equation anymore. I have a balanced chemical equation. Okay, and then I'm going to read this. Okay, in 2 moles of carbon reacting with, what is the coefficient that I have in front? Nothing. That means that I have a 1 in there. Like when you have 1x and you don't put that. If you have x, that means that you have x. 1x in there. So if you don't have any coefficient in front of the oxygen, that means that you have 1 in there. So in 2 moles of carbon reacting with 1 mole of oxygen, 2 moles of carbon monoxide, they are gonna be produced. Questions about? I'm just coming back to this one because remember that one was not balanced. That one was not balanced. So I'm gonna rewrite that. We have we have time just to balance that one because I want you to complete the other ones that you have in there. So I have, in the first example, I have iron solid reacting with hydrochloric acid, aqueous, okay, producing iron 3 chloride solid plus hydrogen gas, which is a diatomic molecule. And when I look at the hydrogen, I have 1 in the reactants. Remember, this is the reactants. The arrow is dividing the reactants from, let me use another color, the products over here. This is my skeleton equation because it's unbalanced. How do you know that, Ms. Ramos? Look at the hydrogen. How many do you have there? Only 1. How many do you have here? I have 2. So looking at the hydrogen, I know that I have a skeleton equation and that I have to balance that. What are you going to use to balance that? Coefficient. But what is your first step? You're going to separate the reactant from the products. And then you're going to start counting. Remember that hydrogen and oxygen, the last one that you're going to count. 1. No problem. I don't have any problem with that. Okay, I don't have any problem with that. Now, am I going to analyze hydrogen? No, that's the last one. Chlorine. I have 1 over here. And on the other side, I have... Ms. Ramos, that's so easy. I'm going to put a 3 over there. Wrong. You have to multiply by 3. And that 3 is a coefficient that you're going to put in front of the compound. If that 3 is affecting both, it's affecting the hydrogen, is affecting the chlorine in there. So now you have 3 chlorines in there. Ms. Ramos, we have a problem. Because if right now we have to count hydrogen, see, we have 3 because that 3 is affecting the hydrogen. Yes, you're right. But on the other side, Ms. Ramos, we have only 2. Yes. And this is when you are going to apply your mathematical skills. There's a number that multiply by 2 that give you 3. There's a number that multiply by 2 that give you 3. No, Ms. Ramos, you're crazy. There's no number that multiply by 2 that give you 3. No one. No, mira, Danelli dice, no. Yes, the scale. 1.5. Decimals are numbers too. 1.5. So in order to make the hydrogen on the other side a 3, you're going to put over here 1.5. We have a problem Can you use a coefficient that is a decimal? No, only whole numbers. Angeli, I don't know what you're putting your hand. I'm figuring, like, I don't know why you're doing this. I don't know, because this is not new. Okay, so can you leave that coefficient as a decimal? No. So you need to multiply that decimal by a whole number, that when you multiply that decimal by that whole number, you have a whole number in there. So I'm going to multiply my entire equation by 2, because when I multiply 1.5 by 2, I have a 3. So after that, see, the entire equation by 2, applying the distributive property, 2 items that are solid plus 2 multiplied by 3, 6 hydrochloric acid aqueous, giving me the 2 that multiply this, 2 iron 3 chloride solid plus 2 multiplied by 1.5, 3 hydrogen molecules in the form of gas. And that's your balanced chemical equation. That is your balanced chemical equation. 2 items over here, 2 items over there. See that? You have 6 and 6. Over here you have 2 multiplied by 3 equal to 6. 3 multiplied by 2 equal to 6. And your equation is balanced. So you have over here your balanced chemical equation, okay? Because when you were counting, over here you have 2 iron, in the products, in the reactants you have 2 iron, in the products you have 2 irons. This 6 is affecting both the hydrogen and the chlorine. So you have 6 hydrogen and 6 chlorine in the reactants. And when you look here on the product, you have 3 atoms, but twice, meaning that you have 6 chlorine in here. And over here you have 2 atoms 3 times, meaning that you have the 6 in the products too. So your equation is balanced. Your equation is balanced in there. Okay, one more time. Remember that when you have hydrogen, oxygen, nitrogen, and any other halogen as part of the product of the reactants in a chemical equation, you have to put the 2 over there as a subscript, because they are diatomic molecules. How are you going to read these balanced chemical equations? 2 moles of iron solids, they react with 6 moles of hydrochloric acid to produce 2 moles of iron 3 chloride plus 3 moles of hydrogen gas. What do I have in here? Okay, so in here, one more time, I have iron, solid iron in there. And I'm going to put that together with copper 2 sulfate. See, solid iron with a solution, a copper 2 sulfate. Copper 2 sulfate, let me put that over there, see, let me see, you can see that from there. That's copper 2 sulfate, a solution in there. Okay, so I'm going to put that together. And then we're going to observe what is happening in there. I don't know if you can see that over there. Do you see that shining color? Okay, we're going to wait a little bit more. See that now? Do you see that now? Do you see that now? Okay, let me. So, the chemical change that you just observe. So, You were observing a chemical change over there because you saw over there a change in color. And if you look over here at this sentence that you have over here, you have the word equation. The word equation that was describing that chemical change. This is a word equation. And why the word equation? Because it's using words just to describe what was happening. I was putting there solid iron in the test tube over there, mixing that with copper 2 sulfate, which was the blue solution, and all of a sudden you were able to see a change in color because that orange solid that you observed in there was the copper, okay? And the solution that you have in there that starts changing color too was iron 3 sulfate. This is the word equation because you're using words just to describe that chemical change. How are you going to write that down in a chemical equation? Remember that in a chemical equation you have to use symbols. So I'm going to start. I'm going to start with my reactants, which are the substance that I have at the beginning. At the beginning I have iron solid, you saw that, plus copper 2 sulfate, aqueous, but because it was in a solution. We don't use liquid, no, aqueous because it was in a solution. Remember that copper sulfate is an ionic compound and it dissolves in water. They were reacting just to yield. Remember that arrow is going to separate the reactant from the product, just to yield iron 3 sulfate. I'm not going to explain how you have to write the formula because you learned that a long time ago. And I was showing you nomenclature. That was the last unit that you were covering. Solid, because it was, no, solid, no, it's not solid, because it was the solution that was changing color in there. Aqueous, plus the copper that you saw there, the copper in there, see, is the copper in there that is deposited, and you know that the copper is solid. Okay, now by looking at the iron, see, you know that this is my skeleton equation. Why skeleton equation? Because it's unbalanced. It's not balanced. I don't have the same quantity of iron in the reactant and in the products. I don't have that. You know that in this side of the equations you're gonna find the reactants. On the left side you're gonna find the reactants, and you know that on the right side you're gonna find the products. Okay, the products. And that's the skeleton equation describing your chemical change, but it's unbalanced. How are you gonna balance that? Remember, your first step is just to divide reactants from the products. Reactant from the products, and then you're gonna start counting. And hydrogen and oxygen are the last one that you are gonna count there in your equation. I'm gonna start with the iron over here. Iron, I have 1 here in my reactants. Iron, I have 2 here in the products. Can I put a 2 over here as a coefficient? No, that's a disparity. You cannot balance your equation using subscript. You're gonna use coefficient. I need to multiply this by 2 in order to have 2, and I'm gonna put my coefficient in front of the iron. Then I'm gonna continue because you're counting. 1 copper over here, copper, 1 copper over here. I don't have problem with the copper. Sulfur, I have 1 over here in my reactant, sulfur. This 3 over here is affecting whatever is inside the parentheses. So I have 3 sulfur in my products. Okay, Miss Ramos, what's gonna happen here? I need to multiply by 3 because there's no way that I can put a 3 under the sulfur there. And that 3 that I'm gonna put in front of the compound is gonna affect everyone, including the copper that was already balanced. Now I have to go back to my copper, see that? Because I needed 3 in my products. So I have 2 irons, 3 copper, 3 copper, 3 sulfur, 3 sulfur, and the last one that I need to balance over there is the oxygen. I have 4 atoms, but I have the 4 atoms 3 times. So oxygen in my reactant, I have 12. Oxygen in the product, I have 4 atoms inside the parentheses, but I have that polyatomic ion 3 times. So 3 multiplied by 4, and my equation is already balanced. So I'm gonna rewrite my balance equations one more time, and I'm gonna start like reading my balanced chemical equation. When 2 moles of iron solid react with 3 moles of copper 2 sulfate in a solution, 1 mole of iron 3 sulfate is gonna be produced, plus 3 mole of copper, they are going to be produced too. And this is my balance chemical balance. This is my balance chemical equation. If you are not sure about that, you check that one more time. Iron, I have 2. Iron 2, but we already did that over here, so we don't need to do that now one more time. We don't need to do that now. Okay? In case that you were unable to see the copper, okay? The copper on the experiment before, look at that, see? Liter by liter, the iron is going to be displacing the copper from the copper sulfate. You're going to be able to see that color in there. But that's not the one that we're going to put together now. Now, this is my third reaction. And in this third reaction, I'm going to put together sodium hydroxide, a solution of sodium hydroxide with a solution of copper sulfate. Okay, the blue one more time. It's the blue one more time. Okay, let me put that there. My copper 2 sulfate. That was the copper 2 sulfate in there, a solution of copper 2 sulfate. And this is sodium hydroxide. See? Sodium hydroxide here. We're going to see what happened. I don't know if you're able to see that there. See? See over there? And it's not moving. What is the evidence that a chemical reaction was taking place? The formation of that solid. See that there? Look over there. Pieces in there. Now, what is that solid? That solid is copper 2 hydroxide. See that? The evidence that a chemical reaction was taking place is the formation of a precipitate. You remember that in chemistry, precipitate doesn't have to do with precipitation. Precipitate has to do with a state of matter. So the solid that was forming there. You can see that over there, see? A solid in there, blue solid that was forming there. Now, if you look over here at the word equation, you have that over there. Okay, the word equations describing the chemical chain using words in there. Once that you have the word equation, how can you convert that into a chemical equation? You need to know how to write, the chemical formula for different compounds. You know that sodium hydroxide is an ionic compound. Remember that we were using a solution plus Copper 2 sulfate is another ionic compound. Both of them, they are made of polyatomic ions. Okay, and according to the word equation, what was produced? Copper 2 hydroxide, copper 2 hydroxide, another ionic compound, plus sodium sulfate. Sodium sulfate. Okay, copper hydroxide was a salt, while the sodium sulfate was dissolved there on the solution. This is your skeleton equation, in which these two, they are the reactants. So everything that is to the left, the reactant, and these two over here, they are the products. They are the products. Okay? So when you look at sodium, in the reactant you have 1, and in the product you have 2. So you already know that you have an skeleton equation. So you need to balance that. How are you going to balance that? And this is the last example that I'm going to cover. How are you going to balance that? First step, you're going to separate the reactants from the products. Second step, you're going to start counting the atoms. Remember that hydrogen and oxygen are the last one that you're going to count in that order. Hydrogen first, and oxygen is going to be the last one. And this is the perfect example because you have both of them in here. So I'm going to start with sodium. 1 in my reactants, sodium. I have 2 over there in the products. So can I put a 2 over here? No, I have to use a coefficient. Let me erase that from here. Okay, so I have to use a coefficient to have my 2, and that coefficient is gonna affect everything that I have in that compound. I'm gonna skip oxygen and hydrogen because those are the last one that I'm gonna balance, and then I'm gonna move to copper. Copper, I have 1 over here. Copper, look over here, I don't have any subscript in there, means that I have 1 in my products. After copper, okay, I have sulfur over here. I have 1 in my reactants, sulfur. I have 1 in my products in there. Now, see, sodium is done, copper is done, sulfur is done. The only 2 elements that are left there that I need to balance are oxygen and hydrogen. I'm going to start with hydrogen. Hydrogen. I have hydrogen here. 1 at the bottom, you don't have anything else in there, but this 2 is affecting everyone. So I have 2 hydrogen in here. Hydrogen, okay, these 2 outside the parentheses is affecting both. So I have 2 hydrogen in there. Oxygen, okay, I have over here 2 plus 4 that I have here. See that? 2 in this compound. Either 2 in this compound comes from the coefficient, plus 4 over here, for a total of 6 oxygen in my products. I have 2 from here, plus 4 from this compound, for a total of 6. So 2 sodium, 2 sodium. 1 copper, 1 copper. 1 sulfur, 1 sulfur. 2 hydrogen, 2 hydrogen. 6 oxygen, 6 oxygen. Now my equation is balance. You're going to rewrite that. So I have 2 moles of sodium hydroxide reacting with 1 mole, because remember that when you don't have a coefficient in front of the element of the compound, that means that you have 1 in there. 1 mole of copper 2 sulfate reacting just to produce 1 mole of copper 2 hydroxide, which is the solid that you observe, plus 1 mole of sodium sulfate, aqueous, because it's still dissolved in that solution. Okay, by the way, you don't know that, but that's the main component that we use in soap. we use this chemical reaction just to obtain this, just to make soap. Okay? And that's your balance chemical equation. Balance chemical equation. Miss Ramos, this topic is too easy. Too easy. Do you have any example of reactions that are difficult to balance? Okay. I'm going to show you one. And here you have an skeleton chemical equation. Water skeleton, but you don't have the word equation. Okay? You don't know how to name that. That's an organic compound. That's butanol. Butanol reacts, okay, with oxygen. You remember that oxygen is a diatomic molecule, so you have to put the two over there. Butanol react with oxygen to produce, okay, to produce carbon dioxide and water. And what? Ms. Ramos, you were putting over there water. Is a gas in there. You know why? Because this is a combustion chemical reaction, and the amount of heat released is so big that the water is going to evaporate, so it's going to be released in the form of water vapor. Okay? So you have your skeleton equation in there. That's your skeleton equation. When you look at the carbon is not balanced. So what is your first step? Pay attention to this, because, see, combustion equations are the ones that are difficult to balance. Okay, so you have 4 carbon over here, and in the product you have only 1. So what do you need to do? You need to put a 4 there in front of the carbon that you have there. Okay? Then the only 2 that you have over there is hydrogen and oxygen. So I'm going to start with hydrogen. I have 10 over here in my reactants, and I have 2. How do I convert that 2 into a 10? I have to multiply by 5. See, and I put that coefficient here in front of my hydrogen, okay, by the way, is affecting the hydrogen to make it 10 and the oxygen. Oxygen, okay, I have 1 over here. 1 plus I have 2 over here by itself for a total of 3. Okay? Oxygen, I have 2 4 times. So I have 8 plus I have 1 5 times for a total of 13. Oh my goodness, Ms. Ramos, how are we gonna balance this? This is complicated. Okay, this is the strategy that you're gonna follow. You're not gonna touch this. See? This compound over here, you're not gonna touch that. Why? Because you have the carbon and the hydrogen balance. Okay, so you're gonna work with this one. So you need a number that multiply by 2 and add a 1, give you over here 13. What is that number? So if you need 13, 13 minus 1 is 12. So you need a 12. What is the number that multiply by 2 give you 12? Boom. And your equation is already balanced. Let me write that down one more time. You have butanol, which is a gas. In the presence, 1 mole of butanol in the presence of 6 mole of atmospheric oxygen, giving you 4 moles of carbon dioxide plus 5 mole of water in the form of water vapor. And this is your balance chemical equation. I'm gonna convert this into a, save this as a video on YouTube, and after I post that on Google Classroom and you watch that. If you have any questions, just write them down and let me know next class.